Hello, and welcome. You know we use numbers all day, every day. I mean, we check the time, we count things, we pay our bills. They are basically the invisible glue holding our world together. But have you ever, really stopped and asked yourself, what is a number? Let's get into it, because the answer is so much weirder and more interesting than you might think.
Yeah, really think about it. I'm not talking about the symbol we write, the numeral 3. I'm talking about the idea of threeness. That thing that a trio of friends, a triangle, and a three-course meal all have in common. Where does that concept live? Is it something we just stumbled upon out there in the universe, or is it something we totally made up in our heads?
And that question, believe it or not, kicks off this huge philosophical brawl that's been going on for literally centuries. It really boils down to two main teams. You've got one side that says mathematics is discovered. We're like astronomers peering through a telescope and finding a planet that was always there. And then you've got the other side who says, no, mathematics is invented. We're more like novelists, creating worlds and rules from scratch.
Now, to really get this debate, we have to start on the first philosophical battleground. It's a field called ontology. It sounds kind of fancy, but all it's really asking is, what kind of stuff exists? For real. So, are numbers real things? Are they just helpful fictions? Or are they something else entirely?
So let's break down the two main teams in this fight. First up, you've got Team Discovery, whose proper name is Platonism. Their core belief is that numbers are real, abstract objects. They exist totally separate from us, our minds, and our world. We just find them. Then you have Team Invention, or Nominalism. They argue that, nope, numbers aren't real things at all. They're just useful labels or fictions we invented to help us describe the world.
Let's dig into Platonism a little more. This view says that the number 3, or the idea of a perfect circle, exists in some kind of abstract dimension. It's not physical, you can't touch it, but it's real. It was there before humans ever showed up, and it'll be there long after we're gone. We aren't creating math. We're just slowly peeling back the curtain and perceiving a reality that was there all along.
But here is the huge, glaring problem for Platonism, and it's a really good question. If numbers exist in this totally separate, abstract realm, if they don't have a physical location or any way to affect us, how in the world do we, as physical, biological creatures, know anything about them? Right? How does my brain connect to the abstract idea of 3? This is the big hurdle they have to overcome.
So that problem brings us to the other camp, nominalism. And the nominalists basically say, hey, let's just make this easy. Numbers don't exist. Problem solved. They see math as an amazing and incredibly powerful tool, maybe the best tool we've ever invented, but it's still just a tool. The philosopher Hartree Field even went so far as to try and rewrite all of Newtonian physics without using a single number, just to prove that we don't have to believe they exist to do science.
So are those our only options, real or fake? Well, not exactly. There's a really clever third way called structuralism. And it says we're kind of asking the wrong question. Math isn't about individual objects, it's about the structure they live in. Think about it like a game of chess. Does it matter if your knight is made of wood or ivory or if it's just pixels on a screen? No. What matters is how it moves and its relationship to all the other pieces. For a structuralist, the number 3 isn't a thing, it's a job. It's the position that comes after 2 and before 4. That's all it is.
Okay, so we've got these different ideas about what numbers are. But that just brings up another deep question. How are we so sure about math? Why are we so certain that 2 plus 2 will always equal 4? This gets us into epistemology, which is the study of knowledge itself. How do we build that rock-solid certainty?
In this search for certainty, 3 main schools of thought popped up. First, there's Logicism. Its big goal was to prove that all of mathematics is just a really complex version of pure logic. Then you have Formalism. This view treats math like a giant formal game of symbols, kind of like chess. It doesn't matter what the symbols mean, as long as the game is consistent and you follow the rules. And finally, you have Intuitionism, which is a pretty radical idea. It says that math is all a mental construction. For something to be true in math, you have to be able to actually build it, step by step in your own mind.
Okay, so this is all really fascinating philosophy, but what's the actual real-world payoff? Like, why should we care if numbers are real or just a game? Well, because we have to somehow explain why this system, whatever it is, works so incredibly well at describing the universe.
And that leads us to what might be the strongest argument for numbers being real. It's called the indispensability argument, and the logic is actually pretty simple. Look at our best scientific theories, general relativity, quantum mechanics. They are soaked in mathematics. So the argument goes, if we believe these theories are actually true descriptions of reality, then don't we also have to believe in the mathematical stuff, like numbers and sets, that these theories depend on? This just perfectly highlights the central mystery, something physicist Eugene Wigner famously called the unreasonable effectiveness of mathematics. It's this deep puzzle. Why on earth does this abstract system of numbers, whether we invented it or discovered it, map onto the physical world so perfectly? It's just so precise, so predictive. It almost feels like a miracle that the universe speaks the language of math.
So in the end, we're left with this massive question. And there's no easy answer. As we get better and better at math, are we just becoming more talented artists, inventing a more powerful and beautiful language to describe the reality we see around us? Or are we more like cosmic archaeologists, slowly and carefully dusting away the sand to reveal the fundamental source code that the universe itself is written in? What do you think?